This is Calculus Homework 1.1b. We're working with tangent line approximations. And our first function is f of x equals x cubed minus 2x plus 5. The very first thing you should do is have a picture in your head of what this looks like. This is a cubic polynomial. And so, maybe it looks something like this, some kind of cubic. You should have a sense of what kind of thing you're working with. And it asks us to write the equation of a tangent line at x equals 1. So what that means is there is some line at x equals 1 that is tangent to this curve. It's a linear function that is tangent to the curve. It barely touches it. And we want to find the equation of that line. So to be able to find the equation of a line, we need two things. We need a point and we need the slope. So we know the x value of the point is going to be at x is 1. So that's our x value of the point. To find the y value, well, we have this function here that tells us what the y value is for every x. So we can just plug in 1. 1 cubed is 1, minus 2 times 1 is 2, plus 5. 1 minus 2 is negative 1, plus 5 is 4. So when x is 1, y is 4. That's the point the tangent line will have to hit. We also need the slope of the tangent line, and we don't know enough calculus to be able to find this exactly yet, but we can approximate the slope by choosing a point very near 1, 4 on this curve. And to do that, I'm going to choose another point nearby. So I'm going to choose x is 1.001. And to find that y value, I'm going to take 1.001 and plug it in for x cubed. Now there's a shortcut trick that will help us here, which is that I can just take 1.001 and store it by pressing the store button, which is right above on. I can press store and store that value into x, and then I can just type in x cubed minus 2x plus 5, and what it's doing is 1.01 cubed minus 2 times 1.01 plus 5. This will help us later on in the problem. And that is about 4.001. Now, I'm not going to use 4.001 when I calculate the slope in a second. I'm going to use this exact number in my calculator so that I have it exact as close as I can to correct. So the way you find the slope between 2 points is we're going to do y2 minus y1 over x2 minus x1. So we're going to do y2 minus y1. So 4.0, I guess here's where I should use this number, 4.001 minus 4, that's y2 minus y1, divided by x2 minus x1. And it tells me that the slope is about 1.003. Now, since this was just an estimate, my guess is that the real slope is actually 1. So the slope is, we're going to use slope is 1. And once you have the slope and a point, we can use that to write the line. We're going to use y equals m, the slope, times x minus x1 plus y1. This is a form of a line. There are other forms as well, but this is pretty easy. The slope here is 1. It's x minus 1 plus y1 is 4. So the equation of the tangent line is this. Now, we could multiply out the 1 if we wanted to. We could not write the 1 because multiplying by 1 doesn't do anything. If we simplify it by multiplying the 1 and adding the 4, you get y equals x plus 3. This is in slope-intercept form. Either one is fine. Both of these would be completely correct answers, and you would get full credit for them. Next, if this is the tangent line, we're supposed to be completing the following chart. When x is 0.9, 0.99, 0.1, 1.01, 1.1, what is the value of the function? Well, when x is 1, we already know the value of the function is 4. When x is 1, we know the value of the tangent line is also going to be 4 because that's where the tangent line intersected. But to verify this, we could plug in 1. Y equals 1 plus 3, which is 4. This is the only point they'll be the same, but we'll be looking at the other values here. On the function, I'm going to use that same trick and put in 0.9 and store it in for x. And then I can just type in x cubed minus 2x plus 5 again, and it'll tell me when x is 0.9, the y value is 3.929. I can do the same thing for 0.99 and see what the y value is. It's 3.99. Note I did not use 3 decimal places here because the third decimal is 0. So this is 3 decimal places of accuracy. And if we continue to do those values, we'll get 4.01 and 4.131. So these are the values of the function that I just get by putting the x value into the function. And I want to see how the tangent line compares. It should be pretty close. Here, I'm going to take these values and plug them into my tangent line approximation. I actually think it's pretty easy to use the slope-intercept one here because it's just adding 3. So when x is 0.9, the tangent line at that x value will be 0.9 plus 3, which is 3.9. When x is 0.99, the tangent line value will be 3.99. And when x is 0.01, we get 4.01 and 4.1, yeah, 4.1, sorry. Now notice these are very close to each other. If I go back and look, I can see that really this was 3.9903. This one is slightly bigger. It's not exactly the same, but it rounds to the same thing. Same with this one. This was 4.0103, slightly bigger. So the third question is, comparing the function and the tangent line, is the function concave up or concave down around x equals 1? Well, again, let's think about what this means. There is the curve, and the curve is always just a little bit higher than the tangent line. So there's this tangent line and the curve, except right here they're equal. At 1 they're the same, but then after that the curve is a little bit higher. And what that tells you is the curve must be bending up away from the line, which tells you the curve is concave up. Since f of x, because f of x is greater than t of x near x equals 1, and because the curve is above the tangent line, the line is going straight, that must mean the curve is bending upwards because they're equal at t equals 1, and so in order for it to be higher, that's what's going on.